Welcome to DESMA, welcome to today's webinar. Again, we are very delighted to have so many participants, again digitally joining us, and we look forward to informing, to explaining and to introducing the DESMA portfolio of roughing solutions as well as the upgraded roughing head and X to you. DESMA's upgraded roughing solutions, including the new roughing head, they allow you to achieve a higher and a better product quality while also allowing you to produce more flexible than before. But before we go into the details and before we actually kick off this session, let us underline that DESMA is and remains committed to fight COVID-19, and thus all necessary measures of prevention have been carefully respected. This leads to a slightly different format of today's event, and we are trying to keep as much and as best as possible distance from each other. But for cases where this is not possible within the DESMA studio, the three people being present in the studio, our expert, our technical expert, as well as me, we've undergone a rapid test just an hour ago, and without revealing too many details and without revealing too many personal information to you, none of us, fortunately, has tested positive. So we are good to go ahead, but we are still trying to keep as much distance as possible. Nevertheless, a webinar or an event also benefits from interaction. And as we are remotely accessing you, we need you to take care that the interaction level is kept at a very high level. So the more questions, the more input you bring to us via the chat function, the better we can create interaction with you. Whenever you have a question, whenever you have something that is unclear to you, please feel free to use the chat function, drop your question, drop your remarks. We will be collecting all those information, we will be collecting those questions, and we are trying to answer them either in the course of today's session or in the course of our Q&A session, which is one of the last parts of today's webinar. Having talked about we, I like to introduce you first to our expert. André Kroker, who is now in this direction in safe distance to me, is our expert when it comes to roughing and automation applications. André is the one introducing you to the DESMA portfolio of roughing techniques, of roughing technologies, and he's also the one answering your questions in the course of the webinar. So let me say, please enjoy the following webinar. Stay tuned, drop your questions. Whenever something is unclear, please feel free to really actively use that method of interaction. So enjoy the webinar and have fun. Before I will hand over to André, our expert, let me just briefly introduce to you the general topic of roughing, as well as in particular the topic of sidewall roughing to you. For this, we have prepared some slides which you can see next to me, and by these slides we like to show you what roughing operations look alike, how roughing operations in the different ways to assemble or to produce a shoe look alike, and from these operations what challenges, what obstacles we can see, and well, maybe whether DESMA has a solution to tackle and to solve those challenges. For an even deeper and more detailed insight on different materials and their requirements when it comes to roughing, we like to refer to our friends from Satra organization. Last week, Thursday, Tom Bays gave a fantastic webinar where he, in detail and with deep insight, explained the requirements of different materials in roughing processes. So when you have the chance, please don't do this right now, but later. So when you have the chance to have an insight into this webinar, please feel free to contact Satra and have a look at their expertise. However, we now like to start, and this means that we start in having a look into roughing and the different roughing applications. The first slide shows to you roughing in direct attaching, or roughing as a general topic. Roughing is, from our point of view, the most important pre-soling and pre-attaching process when it comes to combining both the upper as well as the sole. Because roughing determines the quality and it reduces production as well as finishing steps. So when we look at an upper, and I'm just taking a random one, in general you have the bottom of the shoe with quite good bonding capacities. So roughing is not that important when it comes to the bottom, but it is more important when it comes to the lateral areas of the upper, because here you have different challenges and you have different fields of play. This results from having different materials. This results from different coatings or even different material thicknesses, overlaying, double layering materials, extensive seams, or even complex bite line geometries. So the challenge is to have a repeatable and automized solution which is needed to cover all of the previous and also here listed aspects in industrial footwear manufacturing. Additionally, this solution, and you know this better than we do, needs to be technically robust on the one hand, as well as economically attractive on the other hand, because it needs to contribute to your manufacturing processes. Looking at the next slide, we can see that direct attaching processes do have some special fields of play, which we like to just high level point out here. Direct injected PU needs to develop a permanent compound to the shoes and to the material of the shoes upper. And this means that PU, which is either still in the liquid or in the foaming and creaming phases, needs to penetrate the upper material, and it needs to build up a link up, which is then not to be separated again. And in this process, roughing, especially roughing at the sideline contours around the upper, is very important, because these are the fields where the mechanical forces are at the highest levels. So direct attaching, and this comes from the equipment used in direct attaching processes, requires fast and a precise preparation to not harm, to not reduce the equipment's efficiency. And looking at this and looking at the options or opportunities manual roughing processes offer, you can say that those processes can hardly cope with the high production and fast roundtable speeds, and as well as with the robot-like precision, as well as the repeatability. You know that robots, they don't have a shift end, they don't feel exhausted, they just keep on doing. And so this is one of the biggest differentiation things compared to manual work. The next slide, which is dedicated to gluing and cementing processes, shows, however, that glue, which is representing the medium connecting both the shoe sole as well as the shoe's upper, is the enabler for a best possible connection. Roughing of this close to unique combination, however, is challenging, because the quality of the roughing determines the quality of the bonding between those two usually not ideally fitting components. Usually you have a shoe's upper and you have a shoe's sole. They have some production deviances, so slightly differences in dimensions, in shape. Sometimes the upper is lasted in a different way, and this means when combining those two pieces together, there is slight differences. And roughing of these always changing combinations is a very challenging task, because the glue and the cement, same as with the PU, needs to penetrate the structure, and it needs to establish a firm and precise connection. So roughing in manual or even in automized and gluing and cementing operations, again, needs to cope with the manufacturing speed, and it needs to allow for a constant and ideally a high level of quality when looking at the final products. Summarizing those two slides and looking at the challenges and obstacles we can see in roughing processes, we can separate those in three categories: no roughing, mechanical roughing, or even laser roughing. When we look at no roughing, well, having a leather upper and a PU sole and having no roughing, this usually means that the bonding between those two components, whether direct attached or glued cemented, is usually not too good. When looking at the material surface of the upper, a coating, an impregnation, and looking at the counterparts, PU or glue and cement, we can say that without any roughing into a roughing preparation, those two components do not really start reacting or building up some compounds, some link-ups. So to summarize, no roughing is usually or most often no real option for us. When we look at mechanical roughing, which can either be executed manually by hand with a roughing tool or robot guided with a roughing hat, we see here and there a potential damage and the possibility to have a damage to the upper material. We can also see, especially in manual roughing processes, an inhomogeneous roughing depth. This means, well, having a different pressure to the upper because of different positions of the wrist or the roughing tool to the upper. This results in a different thickness or in a different roughing depth. And this leads to, well, a different bonding capability at this particular position. Then we have complex geometries in the upper and in the roughing areas. And this can lead to the fact that actually roughing is hardly possible with robots. And it's even more impossible to be done by manual hands because the number of axes we have is limited. The number of axes a robot is offering is also limited. So also there can be challenges and obstacles when it comes to roughing, well, really complex geometries. Then we have the fact that the positioning of the upper determines the roughing results. And this is applicable for both for robot-guided roughing as well as for manual roughing. Executed manually, those deviations which I mentioned a little bit earlier may result in heterogeneous roughing results and also in heterogeneous bonding results, and thus the product quality will not be as stable as you're used to, but it might be changing. Well, the last point when we look at laser roughing, which is just a side topic of today's webinar, you need to have very exact parameters for every product and for every material. So copy and paste operations are difficult to realize. So you really need to have dedicated preparation tasks to program the robot and to program especially the laser. And in this context, also the position of the upper on its last is very crucial because the laser is exactly doing what it should be doing. But if the upper is positioned differently, then the result will also be different. And looking at laser operations, we also have to mention that safety precautions in this case are different. So we need to have a different level of safety measures in order to have our working people protected against laser. Actually, that's my slides for now. So this presentation shall just serve as a brief introduction. And when we are now handing over to Andre, we like to learn how to tackle those obstacles, how to tackle and solve those challenges, and to make best possible use of the product portfolio DESMA in this sense can offer. Meanwhile, while handing over, I kindly ask you, and I really kindly remind you to make use of the chat function whenever there was something unclear up to now. But also when you have some further questions which you like us to explain or which you think important of being explained in the course of this webinar. So please feel free to make use of the chat function and enjoy the next section of this webinar hosted by Andre.
Okay, thank you, Tim, for your detailed information so far, and also good afternoon from my side. Let's have a look on the existing roughing solutions what DESMA already have. starting with the direct soling process. Most of our roughing robots are sold together with a direct injection machine. I think many of the viewers know this procedure already. You have a roughing table, a round table. You have your roughing robot on one position. The roughing robot goes one time around the shoe, roughing below the bite line by a width around 8 millimeters. We have a video here which presents you this procedure. So you can have it on a round table like here, directly at one position, or we can combine it also with an Amir conveyor system. Based on our experience, is this one of the most popular roughing applications what we have in the direct soling process. What else? Our Amir C products. With our Amir C products, we want to imitate the typical manual shoe production steps which you need to adapt a sole and an upper together. Normally, you have to rough the upper by manual. You have to cementing the sole and also cemented the upper, of course. You have to cemented the sole. Then you attach both, put it in a press, and you have your ready shoe. Let's focusing on the roughing treatments. Which roughing treatments we have? At the beginning, I want to explain you the grinding process. We have an lasted upper. I will show it in the camera here. And we have the wrinkles here. So the wrinkles give us not a little bit here. Sorry. The wrinkle give us not one line. So we have to level it. Otherwise, it's not possible for us to attach the sole everywhere in the same condition. So for this, we have a grinding process. We have two different options. The first option I want to show you is a big scoring wheel. We can see it here in the video. The robot has the last, go to the Vidia roller and leveling all the folds, hot glue, what you have from lasting. What we also have seen here in the video is a little bit different than the direct injection process. The robot hold the upper or hold the last with the upper and move to the station. So it's similar to the manual process. If I want to rough it, I have the upper here, bring it to the station and rough it. One other grinding solution is our sandpaper station. This we defined for more sensitive materials. We can have fine sandpaper and leveling the folds. Okay, that's our grinding process. Now we have one more process. This is a bottom roughing process. Tim already said that at the bottom you have many points where the sole can attach. So I leveled, I want to show it again in the camera. I leveled now the wrinkles in the front, and now I want to treat this flat surface. I want to open the first layer of the material. For this, we have another product, or we have our bottom roughing station, which has a wire steel brush. This process is a little bit different. It's not grinding, it's more scratching. So the steel wires scratching the leather and open the first surface or the first layer, and the cement can penetrate in the next leather shift. You see it here in the video. This is a bottom roughing process. Of course, we have also different tools, different diameters for the steel wires. Depends on materials what the customer wants to produce. The last process is our contour roughing process. In my opinion, very difficult. We can see maybe in parallel the video. In my opinion, it's very difficult to do this by manual because you have to be very precise on one line. Let us see the video. And you can see the robot do it very precisely and in less time. So I never did it in manual, or maybe once here in our laboratory, but yeah. I think this is more difficult than it looks by the robot. These are our solutions for the AMIRC products. What more, we have also the laser roughing technology. The laser roughing technology could be integrated in both process or in both both solutions. Also in the direct soling process we can integrate it, and also in the AMIRC process. We have a cell solution which works independent, so we need a feeding robot which gives the shoe in the station, or we need a worker who gives the shoe in the cell. But laser roughing is another treatment. Before we're talking about grinding and scratching. So to manual open the surface. Here in laser we're working with a hot beam, which the hot beam burns the first layer of the material that the cement can penetrate or have an open connection to the second layer or to the main shift of the leather material. And this needs, what Tim already mentioned, exactly parameters to handle it, and also between this different between different leather materials, sensitive, stronger materials, you need exactly parameters. I think now it's time to see also the video. It's more logic what I try to explain. Yeah. We can also see that we can burn the whole area, not only an 8mm line. And what is also very important to say is, I want to show you one more shoe in the camera. If we have geometries like this, gaps or some, what it is, flavors or sharp edges, it is not possible, I think everybody knows this, it is not possible to rough this by our typical video roller or by our typical roughing wheel. So our next page will show us some facts for the automated roughing. Next to better working conditions or less VOC in the final product, improve the product quality, I want to tell you something from my own experience. And this sentence is very important. Automatization means standardization. Or standardization can have automatization. Because, let me explain you from this cell solution. I modify a robot program. I take a shoe, lasted it, and generate my program adapted to this lasting upper. So then this is my master. For the robot, it doesn't matter if he roughed just here on the shoe or on the last, or there's nothing. He will do always the same. So our customers, or we have to take care that the final product is always in the same condition or is much stable as it can. This is difficult, of course, with a nature product where we often say every shoe is not similar to the other shoe. But this is one issue. Coming to the next page. Why we have upgraded our most popular application, the roughing head, the contour roughing head. As we can see here in the slide, that the request from the customer is still increasing. And out of our 35 years experience, we sold 1,700 robots, and almost 40%, we can see it in here, there, we can see it there, 40% is only the roughing application. So I remember also in my time as I installed all the machines, normally I have a machine, a roughing robot, and also release agent robot, but mostly roughing robots. We can look a little bit in the on the pictures here, starting with the first or one of the first generations of the roughing head. We just have, let me say, 5 different values. We have 2 different pressures. So if you roughed, you need a pressure, which the roughing tool pressed against the upper. We have 2 different parameters for pressure, 1 bar or 2 bar, that's it. And also 2 different speed parameters. That's it. You can choose it in your program, and then you have 2 different adjustments. Our next robot generation, or our next roughing head, has proportional valve technology. So there we have a much bigger range to adapt the roughing pressure, the turnment, or the roughing result to the products what customers already have. So, and because of this, in addition to many economically aspects, for us, it is the main goal to improve the product to our customers' experience and also to our customers' product. Let's go to the next slide, which presents us a new roughing head NX. If we see this roughing head, my first impression is the absolutely new design. I compare it always with the old one, where I have many sharp corners, pipes, everything. So it's a little bit dangerous, let me say, because sharp corners and many things. This new design, many curves, roundings, of course, reduce the risk of injury. And also the integration or the internally pipe construction is also much more helpful to clean everything. So, what more? The new tool holder is also something, if our viewers compare now everything with the old one, the new tool holder, maybe I can show it here, is bigger, but it's much more precise and stable than the old one. And we know it because we have field test right now, or now we have also the product launch. We know how many cycles this tool holder works already. It's much more stable, I can tell you from my own experience. Yeah, and the newest component in this roughing head is, of course, the electric motor. With this electric motor, I have a big range to control the turnment. I can adjust it from 1,000 till 20,000 turnings. We can see here also a video now, which show us one round. And after this, I also want to explain you something about this video. Next to the adjustment parameters, which give us more range and give us more flexibility, also with thinner leather materials, we can change the turning direction. To change the turning direction could be also helpful. I have some more examples here. First, I want to show you the old one. Oh no, that's a new one. Where I am here. So the old one. For example, overlapping leather materials. You see here, I'm in the focus. Now I'm in the focus. You see here, it's the leather lifted up. Destroyed maybe also a little bit. Now I will show you a new program where we changed the turning direction in here or also in here. Let me go in the focus. You see very smoothly and on the way, I don't know if you have seen it in the video, 3 times we're turning the direction in one cycle. So, what more? You see in the video also some roughing gaps. With the new Descom V4 version, we have the possibility, or we have 3 more software instructions. The first, I explained you already, is reverse the motor. It's just an instruction what you can choose. The other one is a gap. So you can say in one position, I want to have a gap from around 5 to 20 millimeters. And this could be a jump off by some seams or also maybe leather parts, whatever. You can jump off. And the third new instruction is the switching off leather segments. So we have the possibility in correctly one position, we go back with the tool, and on another position, we touch the upper again. And this also very precisely on one point, just instructions in the Descom V4 product. What more further developments also on the vacuum cleaner. The vacuum cleaner, now we see also one time again the video. There we change the turning direction, lifting up 4 seams, again change turning direction and come back. This is what happens there. Further developments in the vacuum cleaner, we have a bigger trash can than the old one, also nice. One bigger improvement is the automatically cleaning system. We have a filter, and the filter can knock, and all the particles what were sticked on the filter can fly down or can fall down in the trash can. So this we can control by a counter, or it's also controlled directly with the vacuum cleaner. It has an independent monitoring system which compared both different pressures. A little bit more detail of the roughing motor. It's an electric drive. I told you already, this electric drive has new bearings and also a torque monitoring system. Means the frequency converter can control the torque, can monitoring the torque. So because of this, we have a longer lifetime than the old one. We can detect some stops or some big moments before. We know this from our field test plus product launch together, that this motor runs without defects more than 2 million times. Then emission and noise reduction, the presentation shows us, and the energy consumption. We see here robot and control is similar because that's the same, but the pneumatic process with the air needs much more energy than the electric. We have just 400 watts, so this is approximately a quarter of the old one. So far, these are my explanations. I hope it was clear. Now I'm also surprised on the questions, what you have. Yes.
Andre, first of all, thank you very much for your detailed explanation, for the deep insight into the technologies and techniques that the portfolio offers. And also thank you for explaining this little beauty a little bit more in detail. Before I'm just switching out of the picture and collecting the questions that we received via the Q&A session or via the chat function, again, please make use of that function because your questions will be answered in the upcoming session. I do have prepared 3 questions which I think of, they might be interesting for our participants, for our users today. And so the first question that I do have is, I do have an old roughing hat. And the question now is this one obsolete? Can I use it?
Absolutely, yes. I think also the old roughing hat has everything. I mean, I work always with the old roughing hat in our laboratory. The old roughing hat has everything what our roughing process need. You need pressure. We have it by the proportional valve technique. We can also control it. We have different motor speeds, maybe not this big range, but because of this we improve it. And we have a continuously robot speed. So all this parameter normally I need for a roughing result. But finally, depends also on customer request, on customer products. We improve many things, what I've also explained, to our customer experience or to our customer products. And we make it better. So let me say the new roughing hat has everything what the old roughing hat also has, but it's still improved and it is a little bit better. I think this...
That is a nice summary of actually the upgrade that we applied to the roughing hat. The second question, you told us a lot about the functions, about the additional functions, the features. From your personal experience, because I know that you're working a lot with customers, with a lot of customers uppers, how do you think of those added, upgraded functions?
This could be still useful, absolutely, and I also work with these functions, but at the beginning I try to do it as simple as I can.
Okay.
And a simple program is just to go one time around with the same instructions, only move point. We also have to think that our customers has to validate their programs too, or has to modify their programs too. So all different instructions what I gave in could be a little bit more complicated, but it gives processes or products where we need these functions. And I can tell you one example from a customer. They roughed sundials on their last, and with the old roughing hat it was not possible because of the turning direction. In one direction it was okay, and on the other side the sundial flipped up or lifted up. So, and because of this it was necessary to change the turning direction, otherwise it was not possible there. Then we use this. And same with seams. If we have problems with the seams that this lifted always up and you see it on the sole edge, for example, then we have to do something, or we have to handle, and then we use this instruction. But at the beginning, I start as simple as I can. And,
well, that's good explanation. And to be honest, I'm convinced of the extended range of functionality, of the extended range of benefits. But the question to me is, well, I like to upgrade now. And how easy can I do this? Is there any limitations?
We say in DESMA we can upgrade it very easy with the new RobotWare 6. This means...
This is the robots that are painted gray, correct?
Absolutely, yes. There we say we can upgrade it, and some modifications, of course, in the software, but it's still easy. The other things we have to double check with our construction department. I think everything is possible. We have to look, but the construction you have to look case by case and have to ask the construction department what they say.
So in general, RobotWare 6 is always possible. All the generations is a case-by-case project evaluation through construction department and our project
this
team.
is what I can answer, yeah.
Okay, super. Andre, at this point, thank you very much for your deep insight. Thank you for answering my first 3 questions. I will now step out of the screen and I will collect the first questions coming in, and you will stay here.
Yep.
So just let me have a second switching out. Andre, a first question. When we look at the roughing tool, which is mounted to the roughing head, and we compare the old roughing head with the new roughing head, is there any time changes in when I have to change this tool? Does it take longer? Is it going faster? Is it easier?
In the old roughing head, we just have, because we have one turning direction, so we have not a second safety screw. Yeah, so with this, we make our experience and we make our tests, how fast we can change this tool. It's around between 60 and 90 seconds. But if we look on this construction, maybe I can hold it here. You see, here is a further screw because of changing the turning direction. Otherwise, on the old construction, this roughing tool will lose if you turn the direction. So because of this, if it is more difficult, I will say not, because it is just a screw. From the seconds, we do it here in 60 till 90 seconds.
So quite fast, you can say.
Yeah, I would say, think not a case.
When we look at the roughing head, you just held it upright. Can you report any changes as regards the dimensions of the roughing head and as regards the shape?
Yeah, the dimension, I thought at the beginning the same, that this looks very big, but we compared it with the old one and also put both construction drawings together in the same size, and this roughing head is smaller. This
okay,
roughing
so
head
looks bigger,
looks,
but it is smaller.
Yeah, it looks maybe because of the brighter or stronger materials. I think it looks a little bit bigger, but it's not bigger. And also what I can say here, for example, the old roughing head, for our viewers, we can check it here. Especially this space here, the old roughing head was flat, like my hand. So I have a little bit, I had more limitation by my axis number 5. If I have some angles at my shoe, and normally here I have my axis number 5 or 4 and can touch the roughing head. But here we have also these curves, and this gives us also a little bit more flexibility. So I can say no.
Okay, that sounds quite good. You mentioned the axis when roughing, and there is one special question from a customer. They think about a roughing cell, and in this cell, when they are roughing, they face some problems with a limitation to the axis or with a limitation as regards the roughing angle. So, from my understanding, the slightly changed design and shape of the new roughing head could be beneficial to this?
Could be beneficial to this, but we have to say if it is a roughing cell, depends also on the position or on the height of the last. The roughing cell solution could be or should be a compact solution, so also a little bit like pick and place by a forklift. Today I need it here and one other day I need it there. So it is a little bit limited in comparing with our direct, if the robot is completely free. But of course, this one gave us a little bit more spacement also here in this cell solution,
Okay, that sounds quite good. There is one customer asking that there is static electricity, which is holding the dust on the shoes after roughing, and for this they use compressed air. Is there any changes when using the new roughing head, or do they still need compressed air to really go against the electrostatic adhesion?
I think the customer asked because of the electricity of the motor that he will suck maybe also these particles.
Maybe it goes in this direction, yeah.
I have not experience at the moment with electrostatic or holding particles in the shoe and then working with the electric motor. Also, I think not, but I have not the experience. I don't try it until now.
Okay. There's one question as regards changing the roughing head. Actually, this connects to the question that I asked earlier. And this customer is asking whether it's possible to change the new roughing head and put it on an old robot. So this goes to the direction of robotware 6, etc., right?
Normally, that's the answer what we already gave. From robotware 6 or our white robots. Our sales department has a go and can sell this new roughing head. If we have older generations, this has to be double checked by our construction department.
Okay.
How it is possible and
If this would work, then there's an old software, Descom version 3, hopefully, and not older. Is the new roughing head also working with this older version of Descom?
Of course, but you don't have these 3 new instructions. But all the old functions are possible. So in the old one, you have also not the functions if you don't need it. It gives one other way to have this. For example, if you have the old Descom system, want to have a new robot, you have the possibility to set these functions by the Desma GRC. This is our customer software on this small teach pendants on the robot. There we have also one more possibility to set these functions. But no, this new software integrations we don't have, but the old functions are still available,
There's one question looking at a complete solution coming from the company Desma, and this customer is asking how Desma is assisting customers to create a kind of pre-program for roughing before starting with a new set of molds. So if the customer is buying a set of molds with Desma and he's using the new roughing head NX, is there any chance to pre-program the roughing?
If you have the CAD files, we can integrate it in Descom, and then
the latest version, I guess.
With the latest version, yes, we have also possibility to do it by the older one, but with the newer one, it's much easier, and it's also adapted to the new head. Yes, also I make these tests just by the new version, so I can be a little bit more practically, but you can do it. You can have the CAD file. And from that CAD file, it's possible to generate also, but let me say a pre-program. We still have to check out which offsets we need, how it looks really and practically. But we have customers who work with this, and we make also sometimes here this, we try this. It is possible.
Oh, that sounds really good, because that also goes to this next question. The customer saying that with a style, each article may consist of different materials, which can require different turning speeds when roughing. Is it possible to use different turning speeds? The first question. And how about programming this different turning speeds? Can I use that program established for a size also for other sizes, meaning scaling up?
One question, also different turning speeds are very easy because you have an article for each shoe, left or right, you have one article, and you can adjust your turning speed in percent from 1,000 till 20,000 turnings. You have also the possibility, that's a little bit more complicated way, but it's also possible to do it in the during the procedure, also during the roughing process. And for example, we working always like the copy-paste principle. So we make one program and then adapt it to the other, or the articles with the parameters of the articles, we adapt it to the other sizes. I hope this is the answer of the question.
So it's mirroring left and right, and it's
mirroring left and right, of course, you can do with Descom, yes.
And you're adapting to the different sizes by scaling up.
You're scaling it up, yeah. But this parameter where you spoke about it, the turning parameter or pressure parameter, are not the program contour. This is integrated in the article parameter, and this we copied for, let me say, one mold series or one upper style, one leather style, yeah.
There's one question about the laser solution that is actually very interesting, not really focusing on the new roughing head, but focusing on the fields of application. And so the customer is asking whether the laser solution can be installed directly at the rotating table of the machine, so at the round table.
Also, at the moment, we have not the solution that we have a handling between this. You can have a human, of course, or a worker who bring this in the laser cell, and later on, we're working with plastic lasts. We cannot work with steel lasts, so we have not an integration directly at the machine. That let us, if we have an example picture in our mind, that there is a cell over our round table. This we don't have. We have still a separate cell solution. So, but this you can combine in your production, for example, that you pre-treated everything with the laser cell and then put it on your round table. Or what we also have is in together with an AMIA system.
Okay, that makes sense, obviously. Andre, at this time, and well, looking at the clock, I'd like to say thank you very much for your very valuable input and for sharing all these details with us. When we look at the schedule of the event, we right now need to come to an end, unfortunately. But I think, speaking for all the participants, I'd like to say thank you very much for your really great performance today.
You're welcome. Thank you.
Super. Well, thank you very much for your attention. Thank you very much for dropping your questions. Those questions which we couldn't answer due to the time, we will answer in later, but by writing an email to you. We know who asked which question, and we will follow up those questions by answering those by email either tomorrow or most likely on Monday. Let us summarize what we just heard and what we just seen in the different videos. Well, we can say the new roughing head NX is, well, really a significant upgrade to your roughing process and also to your roughing quality. It offers a bunch of additional functions which are case by case very valuable for your products and for your production quality. The second aspect that I like to mention is that roughing and automation is a perfect match. So both go together, both go hand in hand, and both do really leverage your benefits when going hand in hand and when being a combined solution. And, well, the third point is that Andre said it earlier in his presentation, roughing is one of the most dominant and most crucial application when it comes to preparing the upper in soling processes, whether it's direct attaching, whether it's direct soling, whether it's gluing or cementing processes. The roughing and also the preparation of the upper is crucial to get a perfect binding between the two components. And thus an upgrade to your roughing capabilities for us also means an upgrade to your roughing performance. Well, before saying goodbye, we like to let you know that by next Monday you will receive an email from us. This email will have a fact sheet attached. The fact sheet is summarizing the event, and this email will also contain a link. And via this link you can review today's session. You can review either for yourself or with colleagues who were unable to join today's session. And with this question, with this email, also we will start answering those questions which we couldn't answer in today's session. However, if you're replying to this email with further questions, with more specific precise questions as regards your equipment, we will of course also answer those or forward those to our project team or to your sales representative. But at this point, and now looking, it's 3:29, so we are completely perfect in time. I'd like to say thank you very much for your attention. Thank you for joining, and thank you for interacting with us. We had a great time. We hope that you had a great time too. And at this point, I'd like to say, stay happy, stay healthy, and see you soon with Desma. Bye-bye.